Hi everyone, welcome back to our channel. This video is brought to you by Key Tutor. I am your presenter, Tawab Salasi Taklamariam. Today we are going to present you grade 8 mathematics, and this will be the first unit and session 1. Grade 8 mathematics has got 8 units. The first unit is concerning rational numbers. The second unit is about squares, square roots, cubes and cube roots. The third unit is about linear equations and inequalities. The fourth unit is about similarity of figures. The fifth unit is concerning theorems of triangles. The sixth unit is about circles. And the seventh unit is about solid figures and measurements. And the last unit is concerning introduction to probability. This is going to be elementary probability. Today we are going to start with rational numbers. The first subtopic is the concept of rational numbers that has got 3 more subtopics. The second subtopic is about comparing and ordering rational numbers. The third one is about operations and their properties of rational numbers. The fourth is real-life application of rational numbers. Let us just dive into the first unit, learning outcomes. After completing this unit, you will be able to 1. Define and represent rational numbers as fractions. 2. Identify the relationship among natural numbers, whole numbers, integers and rational numbers. The third learning outcome is representing rational numbers on a number line. And the other one we want to cover is compare and order rational numbers. Define absolute value of rational numbers. Compute basic operations on rational numbers. And the last learning outcome is apply rational numbers to solve practical problems. Now let's dive into the first concept of rational numbers. This time we want to define concepts like natural numbers, whole numbers, integers, rational numbers. Let's go on. You have defined natural numbers in your grade 6 and 7 as counting numbers. It is denoted by capital N, and the set starts with 1 and it goes like 2, 3, 4, 5 and so on. The set of whole numbers is another set which includes all the elements of natural numbers and adds up a 0. So this time whole number starts with 0, except the 0 we have in whole numbers. Every other number is a natural number in the whole numbers. Now let's see integers. The set of integers is denoted by Z, still kind of decorated one. It has got negative integers, -1, -2, -3, -4, goes to the left, and starting from 0 goes like 0, 1, 2, 3, 4. Now from time you can see here the sets are being larger and larger. They are adding up one element, and sometimes in the case of integers more numbers, the negative numbers. Now it is very clear that we have this relation. The natural numbers are subsets of the whole number because every element in the natural number belongs to the whole numbers, and every element or every number in the whole number belongs to Z, which is integers. So the natural numbers are subsets of whole numbers and the whole numbers are subsets of integers. And this is true also. Natural numbers are the proper subsets of whole numbers and the whole numbers are proper subset of integers. Now here an additional concept is the concept of rational numbers, which is the focus of this chapter. A number that can be written in the form of a over b, where a and b are integers and b is different from 0, is called a rational number. The set of rational numbers denoted by q, and it is defined by q equals represents the set of rational numbers in the form of a over b, where a and b themselves are elements of integers and b is different from 0. This is very important. It is of the form a over b, where a and b are integers and b is different from 0. Let's continue. Relations between natural numbers, whole numbers, integers, and rational numbers. This relation we have already seen it. We want to clearly see here using a Venn diagram. So you see, the natural numbers, as we have previously discussed, is a subset and even a proper subset of whole numbers, and the whole numbers are subset and even a proper subset of integers, and the integers are subsets of rational numbers. Here, that is what we have trying to see. Using a Venn diagram, this is how it goes. A set of natural numbers represented by a circular Venn diagram. Now the set of whole numbers, the yellow Venn diagram. The set of whole numbers, as you can see, includes the set of natural numbers. Of course, the whole numbers are different from that of the natural numbers because they have included 0. And now comes even a bigger set, which is the set of integers. Right? The set of integers includes the set of whole numbers and adds up negative integers. The last set is the set of rational numbers, which includes the set of integers and as well as fractions. Here and there I have been mentioning fractions. Fractions are numbers which are written in the form of a over b. A and b are integers and b is not equal to 0. In the fraction a over b, a is called the numerator and b is called the denominator of the fraction. So let's note, in a fraction plus or minus a over b, while the plus or minus sign indicates the sign of the fraction. If it is positive, you take a plus sign, and if it is negative, a minus sign. Either of the signs you have for the fraction a over b, disregarding plus or minus, if a is less than b, then the fraction is said to be a proper fraction, but otherwise the fraction is said to be improper fraction. Meaning, if a is less than b, the fraction plus or minus a over b is a proper fraction. If a is greater than b, the fraction is improper fraction. Now let's take example just to show what proper and improper fraction look like. Take 2 over 5. You see, the numerator 2 is less than the denominator 5. In 3 over 10, the numerator 3 is less than the denominator 10. In 13 over 16, the numerator 13 is less than the denominator 16. These 3 fractions are simply proper fractions. In the case of 5 over 2, 17 over 12, 105 over 16, in each of them the numerator is greater than the denominator. These fractions are simply improper fractions. If an improper fraction is expressed as an integer and a proper fraction, then it is called mixed fraction because it is expressed as integer with a proper fraction. That makes it mixed fraction. Note here, every improper fraction can be changed into a mixed fraction by division. Let's take numbers like 5 over 2, negative 127 over 10, 93 over 16. In each of them, you can see that these numbers are improper fractions. How can we change them into mixed fraction? As they are improper, we can change them into mixed fraction. Later on, we will see what the importance of changing improper fraction into a mixed fraction. Okay, 5 over 2, if you try to change it to a mixed fraction, what you do is that you divide 5 by 2. When you divide 5 by 2, you get 2 and the remaining is going to be half. Okay, you can write 5 like 4 plus 1, and 4 divided by 2 is 2. That's how you get 2 for the integral part and half for the proper fraction part. So you see, 5 over 2 is written in the form of what fraction? Mixed fraction, where you have 2 as integer and half, which is a proper fraction. Similarly, you can consider negative 127 over 10. This is obviously improper fraction because 127 over 10, 127 is greater than 10. So now 127, you can see that it can be written as 120 plus 7, and the part of 120, when you divide it by 10, it gives you 12. 7 remains, it gives you 7 over 10. So this is simply negative 12 and 7 over 10. So this is a mixed fraction. And the last one we want to consider is 93 over 16. In 93 over 16, this also can be written as 80 plus 13. So the 80 part gives us, when you cancel it by 16, you get 5. So the remaining 13 with that of 16, it gives you like 13 over 16. Together you have 5 and 13 over 16, which is the mixed fraction form of 93 over 16. So altogether the fractions 2.5, negative 12 and 7 over 10, 5 and 13 over 16 are mixed fractions. Now the next topic we want to see is representation of rational numbers on a number line. Okay, this is how you represent integers on a number line, right? You label at certain equal distance from the right and left of 0, positive integers to the right and negative integers to the left. So you represent, make sure that these numbers are distributed, these integers are distributed at equal distance. That gives us the scaling of the number line. Now we want to represent rational numbers on this number line. First off, we have seen integers can be represented on a number line. Now we want to represent on the same number line rational number. For example, let us try to represent 5 over 2 on this number line. Previously we have seen that 5 over 2 is 2.5 when it is written in a mixed form, okay, in a mixed fraction. 2.5 is obviously halfway between 2 and 3, right? So you may expect it to be right here, okay, and this is where you just can't expect it to be 2.5 between 2 and 3, because 5 over 2 is 2.5, so you go 2 units to the right of 0 and half of a unit exactly at the midway between 2 and 3. Then what does it mean? It means just right here you need to have, right there you have a scaling for 2.5, okay? So 2.5 is just right there in the midway between 2 and 3. Now let's take another number. For example, negative 5 over 3. Negative 5 over 3, when it is written in a mixed fraction form, it is just negative 1 and 2/3. Observe that this number, negative 1 and 2/3, is between negative 1 and negative 2, or simply between negative 2 and negative 1, okay? And it is 2/3 of the unit between negative 1 and negative 2. And to get this 2/3, what I should do is I have to divide the line segment between negative 1 and negative 2 evenly into 3 equal parts. Maybe right here you could have one label, here you can have another label. So you divide the line segment between negative 1 and negative 2 into 3 equal parts, just this way. So here you divide it into 3 equal parts. Now the next thing you need to do is just to what are these things represent on the number line. This is 1/3 from negative 1. This one is 2/3 from that of negative 1. Okay, but what I need to locate is negative 1 and 2/3. That is a point which is a little bit near to negative 2, obviously. Thus, negative 1 and 2/3, which is negative 5 over 3, is right here. Okay, negative 5 over 3 is right here. Now let's have exercise. Consider the number line below and find the value of p. Okay, here you can see the number line that is divided into 5 parts, and we want to find what the value of p is. Okay, and the one thing you can see here is you start at 1 and you end up at 3.5. You can consider these things as given to get the location of p. What you need to do is that first, how long is between 1 and 3.5? To get that, you subtract from 3.5 1, you get 2.5, and the gap between 1 and 3.5, as you can see, is divided equally into 5 equal parts. Then the second one is exactly right at b. Okay, so the first thing is how long is the distance between 1 and the first division point, the second division point, the third division point, the fourth division point. That divides the line segment between 1 and 3.5 into 5 equal parts. That's what we want. To get that, you need to divide 2.5, which is the length between 1 and 3.5, by 5, and it gives you 0.5. Okay, so each subdivision of the line segment into 5 equal parts gives me 0.5 units, and then B is 2 more units. So you start with 1, you add 0.5 and another 0.5, which gives us 2. So the position of B is 2. The other topic we want to cover is absolute value of rational numbers. First off, let's define what is meant by absolute value of rational numbers. The absolute value of a rational number x, denoted by absolute value of x, is denoted as follows. Absolute value of x is equal to x if x is greater than or equal to 0, and it is equal to negative x if x is less than 0. For a beginner, understanding this is a little bit difficult, but let us try to explain what it is with an example. Simplify each of the following absolute value expression. We want to simplify absolute value of 8 minus 3, negative 25 plus 13, 0 minus 10. Okay, let us start with absolute value of 8 minus 3. Absolute value of 8 minus 3 is when you take the inside part, 8 minus 3, it is 5. And as you know, 5 is positive, greater than 0. So, what is inside will directly get out, which is absolute value of x is x itself, x, when x is greater than or equal to 0. And as 5 is greater than 0, then absolute value of 5 is nothing but 5. Now let's consider what is absolute value of negative 25 plus 13. First, let's take the number inside. Let us calculate what it is. So you get negative 25 plus 13 is negative 12. Yeah, negative 12 is less than 0. Okay, here you are. X less than 0 implies absolute value of x is then negative of x. What is less than 0 in our case? Negative 12. Absolute value of negative 25 plus 13 is absolute value of negative 12. Then it says negative of what is inside is the absolute value of what is inside. So negative of negative 12 is then 12, positive 12. So still, this absolute value thing is giving me positive numbers or 0. And the last thing is the case of absolute value of 0 minus 10. So the difference is obviously absolute value of 0 minus 10 is negative 10. Negative 10 is less than 0, and we're going to have the definition of absolute value, which is the second part definition. We have absolute value of 0 minus 10 is absolute value of negative 10. As negative 10 is less than 0, you take the negative of 8, negative of negative 10, that makes it to be positive 10. Now let's continue concerning equation involving absolute values. An equation of the form absolute value of x is equal to a for any rational number a is called an absolute value equation. So here it is an equation because there is equal sign. Let's consider geometrically what it means when absolute value of x is equal to 8. What is the meaning of that? This time we are thinking of what is inside the absolute value has a distance 8 units from 0. In our case, this distance can be to the right, which leads us to positive 8, and it can also be to the left, that gives us negative 8. So in the first case it will be positive 8 to the right, negative 8 to the left, and both these distances are 8 units from that of 0. Okay, they are 8 units away from that of 0. Okay, so what does it mean? Absolute value of x is equal to 8 means the distance of x, right, whatever inside, is 8 units away from 0. Okay. Absolute value of x now is considered as distance. The values of x that are far away 8 units from 0 are either 8 to the right or negative 8 to the left. Let's have some more practice of equations involving absolute Let's continue what we have seen there. So we are going to have three versions for equations of absolute value. The first case is having two solutions. If a is greater than 0, absolute value of x is equal to a has two solutions. Those are x equal to a and x equal to negative a. Now, if a is 0, absolute value of x has one unique solution, which is x is 0. If a is 0, then x is 0. And if a is less than 0, this absolute value of x has no solution, meaning distance cannot be negative. Therefore, absolute value of x cannot be a negative number. Now let's try to solve the following problems. Solve the following absolute value equations. Absolute value of x is equal to 13, b absolute value of x is equal to 0, c absolute value of x is equal to negative 6. To solve absolute value of x is equal to 13, first off, look at 13. That is what decides the type of the solution is. As 13 is positive, therefore absolute value of x is equal to 0 has two solutions. X is 13, x is 13, and x is negative 13. So these are the two solutions. Now let's consider the case of absolute value of x is equal to 0. This is as in the case 2, which is a one solution case. Absolute value of x is equal to 0 implies x is 0. The other thing is absolute value of x is equal to negative 6. We have said that a distance or length cannot be negative, right? That is the third condition, which is a no solution case because negative 6 is obviously less than 0. Now let us consider more equations that involve absolute. Let us consider the case of absolute value of x plus 7 minus 7 equals negative 7. Okay, we first do the balancing, right? Just to eliminate negative 7 from the side of that involves absolute value, we add 7 both sides. Okay, we just add 7 both sides. So here negative 7 plus 7 is 0, negative 7 plus 7 is 0. Then this is what you have. Absolute value of x plus 7 equals 0. And this happens only if the inside part is 0, which is x plus 7 is 0. If x plus 7 has to be 0, just to get the value of x alone, we have to add both sides negative 7, right? You add here negative 7 and there negative 7, which means you subtract both sides 7. When you subtract both sides 7, you get the value of x to be equal to negative 7. Okay, absolute value of x plus 7 minus 7 equals to negative 7, provided that x is negative 7. That is the only possibility. Now let's consider b, which is absolute value of x minus 5 plus 5 is equal to 4. Here, this equation. That is an absolute value of equation. To solve that, we go as in the previous. We add both sides negative 5, or we subtract 5 from both sides. Okay, so you subtract 5 from here, and there you subtract 5. 5 minus 5 is 0, 4 minus 5 is negative 1. Therefore, this is true if and only if absolute value of x minus 5 is negative 1. Now, right here, you don't go further. On the left side, you have absolute value of x minus 5. On the right side, it is to be equal to negative 1. So the absolute value, whatever in the absolute value, we cannot get it to be negative. The case is a no solution case. That's it. Now let's go to 3 plus 2 times absolute value of x plus 3 is equal to 9. Well, this looks a little bit complicated, but let's see how we treat such problems. The first thing you do is you subtract from both sides 3, right? So when you subtract from both sides 3, you get on this side 0, on the other side 6, right? Which means twice absolute value of x plus 3 is 6. Now this is what you did. You subtract 3 from here, right? And also here you subtract 3. So you get 3 minus 3 to be 0 on this side, and 9 minus 3 is 6. Altogether what we have is simply twice absolute value of x plus 3 is equal to 6. Now you divide both sides by 2. You divide this one by 2 and you divide this one by 2 as well. So you get what? You get absolute value of x plus 3 equals to just 3. Okay. This is a two solution case because the value of a here is positive. Okay. Then the inside number, that is x plus 3, either it is 3 or it is negative 3, or simply the inside number x plus 3 is negative 3 and x plus 3 is positive 3. So this is what you get. X plus 3 is negative 3 and x plus 3 is 3. Okay, so x plus 3 is negative 3 implies when you solve, you subtract from this side negative 3, 3. From this side you subtract 3, and from the other side also you subtract 3, and for the other side you still subtract 3, and from here also you subtract 3. Okay, so x plus 0 is equal to negative 6 for the one on the left, and from the other equation you get x plus 0, 3 minus 3, is equal to 3 minus 3, which is 0. So together you get simply x equal to negative 6 or x equal to 0. The last thing you want to see is 3 minus twice absolute value of x minus 6 is equal to 5. Okay, so as usual you subtract 3 from here. You just subtract 3 from here to eliminate a constant from both sides. So in that case 0 minus twice absolute value of x minus 6 is equal to 5. That's what you get. 5 minus 3, which is 2. Thus negative 2 times absolute value of x minus 6 equals to 2. Okay, this is negative 2 times absolute value of x minus 6 is equal to 5 minus 3, which is 2. Okay, now the next thing you need to do is you divide both sides by negative 2. Okay, when you divide both sides by negative 2, then you get obviously the following relation. To the left, negative 2 over 2 is 1, so 1 times absolute value of x minus 6 is simply absolute value of x minus 6, and negative 2 over 2 over negative 2 is negative 1. So what do you get? Absolute value of x minus 6 is equal to negative 1. What does it mean? It means you need to solve this equation, which has no solution because the value of a now is negative 1. That's the last thing we have. This time we finish our lesson for today. Next time we'll discuss the next topics like ordering rational numbers, comparing rational numbers will be the next topic we are going to see. Till then, please like this video, comment, share and subscribe. Tell your friends to share and subscribe and like and comment on this video. Thank you very much for staying with us this long.